Let's finish up section 3.2 with example 2. So we have seen this data before. Again, this is the sample of gas prices in an area. So will this represent a parameter or a statistic? Okay, a parameter or a statistic. So remember, parameters are based on a population, and statistics are based on a sample. And since this is a sample, we are talking about a statistic. Okay. From the example then, back before, we know that the mean is 2.788 per gallon, $2.78.8 a gallon, essentially. The symbol for that, remember, the mean is X bar. All right, and then we're going to find the range of the data. Remember, the range is the highest value minus the lowest value. So that's $2.86 minus $2.75 for a range of 11 cents per gallon. Okay, so there's the range, how much the prices differ from high to low. All right, find the sample standard deviation. Again, notice we have a, didn't mean to use that, I'm going to use the highlighter. Sample standard deviation uses the lowercase letter s. So population standard deviation uses the sigma. Okay, sample standard deviation uses an s. And we're going to use our calculator to do that. So again, you're going to go back to the one variable stats after you put that data in your calculator into L1 or wherever you're going to put it. Do one variable stats, and this time on your calculator, instead of looking for sigma, you're going to look for the one that is an S, X on your calculator, but we'll use just S when we write it down. Okay, and we're going to go one decimal place past the data. So that should be 0.034 cents per gallon is where we end up, okay? And do notice there is a difference. If you look at the value of sigma and the value of S, even though they're both standard deviation, there is a difference between them. So it is important that you choose the correct one based on whether your data is about a sample or about a population, okay? So interpret the sample standard deviation. So we can do this very much the same way. So the gas prices differ from the mean. Of $2.788 cents per gallon by about $0.034 or 3.4 cents per gallon on average. Okay. And again, you can start to tailor that to a way that fits you and how you like to phrase it. All right, are there any outliers? So remember, we're going to be looking at two standard deviations below and above the mean. So we're going to do the low end and the high end. So we want the mean minus the mean, let me use the right notation though. This is an X bar because we're talking about a sample standard deviation. So X bar minus 2S, on the high end X bar plus 2S. So 2.788 minus 2 times 0.034. And 2.788 plus 2 times 0.034. On the low end, that's $2.72. On the high end, that's 2.856. Okay, so if you go back and look at the data, we will find that there is a $2.86, and that therefore is an outlier, happens to lie just to the right of our upper boundary. All right, so we talked about range. We did that in question C, and then we just did the standard deviation, and which one is going to be better. When you talk about how spread out the data is there one that you should or is recommended to choose over another? All right, so let's talk about that just for a second. The standard deviation, when we did that calculation by hand, if you remember, okay, standard deviation uses every data value. Okay, so in some ways, standard deviation, which we will abbreviate SD, okay, some ways standard deviation is a more accurate measure of how spread out the data is. The downside of that is it is a complicated calculation. Time-consuming calculation, okay? Takes a while. Range, again, kind of the downfall. So it uses only 2 data values. The maximum and the minimum, the high and the low, or however you want to say it. So you can kind of look at this as a quick and dirty measure of the spread of data. Okay, it is very simple. But it certainly, I mean, it ignores, when you think about it, range ignores all data values except 2. It doesn't matter what anything is in the middle. It's only about the high and the low. So as you can probably tell, it may not be the best way. But again, it is kind of a quick and dirty way to do it. All right. So again, some notations here. Some should be review, and some, well, they should all be review at this point. We're just going to formalize it. So population, when we're dealing with a population, sample size is a capital N, mean is mu, standard deviation is sigma. Okay, population gets all kind of the big fancy ones. They get all the Greek letters and they get the capital letter, because think capitals, those are the big letters, right? Sometimes you learn that when you were little. Oh, those are the big letters. So population is big, okay? N, mu, and sigma. On the other hand, for the sample size is lowercase n, mean x bar, sample standard deviation, a lowercase s. Okay, and then I'm going to have you give a little thought to what it means if a data set has a standard deviation of 0. That is one of those concepts we are going to discuss whenever we talk together online in person, or it may pop up on the forum, but whichever way, make sure you are a part of that conversation so you start to get a greater understanding of standard deviation.